Tsunamis are some of the worst natural disasters in all of nature. They're extremely destructive waves and destroy lots of infrastructure around the coastal areas and cause loss of life, which is why it's essential that we have early warning systems in place to allow countries or coastal cities to evacuate out of the area when we predict a tsunami is coming. For example, in 2004, the Boxing Day tsunami, which hit Indonesia and many other countries around the Indian Ocean, had a death toll which exceeded over 200,000. Which is why new research has come out suggesting that we may be able to use AI and technical hardware to help predict these tsunami pathways. You see, when an earthquake is triggered under the ocean, it is the vertical motion of the slip which determines how big a tsunami is. Therefore, the vertical movement of the tectonic plates upwards or downwards can displace the water column, creating large tsunamis. And researchers from the University of California have come up with a new technique which could help save time to determine whether a tsunami will be triggered by an earthquake. They're using a mixture of AI and hydrophones. Now, these are essentially underwater microphones that listen for very key sounds under the oceans. And these hydrophones essentially measure the acoustics of the oceans, which means when there's an earthquake and the seismic waves propagate through the waters, these hydrophones will pick them up. And researchers want to use these hydrophones to measure the acoustic radiation or sound of an earthquake thousands of kilometers away before the tsunami reaches a location. And the important thing here is the sound itself travels much quicker through the water column than the tsunami wave does, therefore providing vital time that's needed to evacuate a coastal area. And the AI plays its role in understanding the data that these hydrophones collect. They can create computational models once they have enough data, and the AI engines themselves will be able to distinguish and triangulate where the earthquake is, and with enough data can determine the slip once we have more information on whether it was a vertical or a horizontal earthquake. And over time, the AI will get smarter and smarter in understanding the recorded signatures and then give us an answer as to whether there is a potential for tsunami or not. Time is of the essence, especially when you have a wall of water coming at you at hundreds of meters per second. Thank you for watching, and I'll see you in the next one.